How to plot a polar plot for Astro 12 by Azul Celeste Rodriguez. Throughout this video, if you need some more time to read what is on screen, or if you need some more time to process what you are seeing on screen, please feel free to pause the video. This tutorial will use fake data. These data were collected using Stellarium and taken from an observation site in Brazil. Please use your own lab data when performing the actual lab. Anytime these data will be used in the tutorial, they will appear on screen, so there is no need to write this down. A polar plot has two components, an angle around the perimeter and a radially inward direction. For our plots, azimuth is the perimeter around the edge. In the given graph, each section is 10 degrees of azimuth. The top is north and the left edge is east. This is normal for the sky. A lot of students get a little confused here and they think about terrestrial maps and they go, shouldn't west be on the left? And when you hold this map up to the sky, if you align north where north is and south where south is, east will actually be on your left. So this is not a mistake. Altitude is the radially inward direction. In the given graph, each ring represents 10 degrees of altitude. The horizon is the outermost ring, and as you go inward, they increase by 10 degrees for every ring that you cross. The zenith is in the center of the graph and denoted by a cross shape. So we're going to start at north and we're going to work our way around that outermost circle around the horizon toward the east. When we arrive at the azimuth value for our data point, we are going to stop and then begin our movement radially inward for the altitude. So for example, for this 8 p.m. data point, we would move 140 degrees in azimuth around the outward edge, and then we would move inward 39 degrees. That would be crossing 3 rings and almost getting to the 4th one. I'm going to show you the plots for this entire data set, and if you need time to process what you were looking at, please feel free to pause the video. So this is data point 1, azimuth 140, altitude 39. Data point 2, azimuth 142, altitude 44. Data point 3, azimuth 145, altitude 48. Data point 4, azimuth 149, altitude 52. And data point 5, azimuth 154, altitude 55. Once you've finished plotting, you're going to want to draw a smooth curve to try to fit your data. This is not asking you to draw a straight line connecting the dots. It's asking you to draw a smooth curve that fits where the data's overall shape is. You're going to want to include an arrowhead to indicate the direction of forward time and to label the curve with the star name. So this is the star Canopus, and you can see that there is a curve that's going through our data, and the end of the curve has an arrowhead on it indicating that the time is increasing from east to west. That's it for this tutorial. Let me know if you have any questions on how to do this graph. Thanks.